Welcome to another video lecture. In this video lecture, we will discuss example problems on a root locus. So let's take one example problem. So in this example, let me write here. In this example, the value of GSHS is given as equals to K by S plus 3, S plus 5, and for this system, we need to draw the root locus. Draw root locus for the system. Now, to draw the root locus for the system, we already discussed in the previous lecture. There are some rules or steps to construct the root locus. So, in the first solution, now to draw the root locus, the step 1 is, first of all, we will need to calculate how many poles are there in this question. So, we can say that S is equal to 0, S is equal to minus 3, S is equal to minus 5. There are 3 poles. So, the value of capital P is 3. Number of zeros is 0, since there is no 0 in this system, and P minus Z, number of separate branches of root locus is P minus Z, which is 3 minus 0. So, this is 3. So, there are 3 starting points of the root locus, and none of them terminates at 0, since there is no 0. All the 3 branches, since there are P minus Z is equals to 3, there are 3 separate, let me write here, separate branches of root locus. All these 3 separate branches of root locus terminate at the infinity. So, let me write here the starting points. Starting points of the root locus will be the poles, which is S is equals to 0, S is equals to minus 3, and S is equals to minus 5. The ending points will be ending points, since there is no 0 in this question. So, the ending points will be infinity, infinity, and infinity. All the 3 branches will terminate into infinity. Now, step number 2. In the step number 2, we will find out the pole 0 plot. Pole 0 plot of this problem. So, let me draw here a pole 0 plot in which we have a real axis and imaginary axis, j omega axis, and in this we will locate all the poles and zeros. So, we have poles at S is equals to 0, we have one pole at S is equals to 0, we have one pole at S is equals to minus 3. So, S is equals to minus 3, and at S is equals to minus 5 we have another pole. So, S is equals to minus 5. So, we have 3 poles at 0, minus 3, and minus 5. So, this is the pole 0 plot. Now, to find at which section of a real axis root locus will lie. So, let us suppose there is a point here between 0 and minus 3. Let me again put this here. So, suppose let me highlight this point. Okay, so here suppose we have a point between minus 3 and 0, and we want to find out whether this section 0 to minus 3 will lie on root locus or not. So, what we will do, we will calculate number of roots on the right side of this point. So, as we can see that there is a single root at S is equal to 0 on the right side of this point. So, we can say that this section 0 to minus 3 will lie on the root locus. So, let me highlight this with the different color. So, this section from 0 to minus 3, it will lie on the root locus, and also we know that root locus start from the poles. So, this will start from this point and this point also. Hence, we can also predict from this discussion that there must be a breakaway point. There must be a breakaway point between 0 and minus 3. So, exact position of breakaway point we will later find out in step number 5, I guess. So, this breakaway point will lie between 0 to minus 3, and this section 0 to minus 3 will lie on the root locus. Now, let us take another point between minus 3 and minus 5, and we need to find out whether this point minus 3 to minus 5, this section minus 3 to minus 5 will lie on the root locus or not. What we will do, we will calculate total number of roots on the right side of this point, which is denoted by a pink point. So, there are a root on minus 3, there is a root on 0. So, there are 2 roots on the right side of this point. Hence, we can say that root locus will not lie in this section minus 3 to minus 5. So, let me again write here in this section minus 3 to minus 5 root locus will not lie. Now, from minus 5 to minus infinity, to find out whether root locus will lie between minus 5 to minus infinity, let us again consider a point, suppose here yellow one. So I'm denoting it by a yellow point. So on the right side of this yellow point there are 3 roots on minus 5, minus 3 and 0, and this, which is an odd number. So we can say that root locus will lie on this section minus 5 to minus infinity, and it will start from minus 5 since it is a pole, and it will terminate at minus infinity. So this branch of root locus will lie on the real axis, and it will start from minus 5 and it will terminate at minus infinity. So overall, from this discussion we can say there are 2 branches of root locus which will lie on the real axis. One which is start from 0, terminate at minus 3, which starts from both 0 and minus 3 and terminate at the breakaway point, and the another branch which will start from minus 5 and terminate at minus infinity. So out of these 3 separate branches, we have found that 2 branches of root locus will lie on the real axis. Let me write these points here. 2 branches lie on real axis, and breakaway point lie between 0 and minus 3. So this is the conclusion of this point. Let us move to the next point. In step number 3, we will find the angle of asymptotes. So we know the formula of angle of asymptotes. Theta is equals to 2q plus 1 divided by p minus z into 180 degree, and q will be 0, 1 and 2, since there will be only 3 asymptotes, since there are 3 branches which terminates at infinity. So value of q will be from 0 to 2. Now for q is equals to 0, we will get theta 1, which is equals to 180 divided by p minus z. Since p minus z for this problem is 3, so this will be 180 divided by 3, so this will be 60 degree. Theta 2 for q is equals to 1, we have theta 2 is equals to 2 plus 1 divided by p minus z is 3 multiplied by 180 degree, so this will be 180. And theta 3 is for q is equals to 2, is theta 3 is equals to 2 into 2 plus 1 divided by 3 into 180 degree. So this will comes out to be 300 degree, or you can say minus 60 degree. So these are the 3 angle of asymptotes for this question. Now in step number 4, we calculate the centroid. Now the centroid is the point of intersection of asymptote with the real axis. So the centroid value C is given by summation a real part of open loop poles minus summation a real part of open loop zeros divided by p minus z. So since we have poles at s is equal to 0, minus 3 and minus 5, and zeros we have nothing, no zeros is there in the question. So the value of C is equals to real part of poles, which is 0, minus 3, minus 5, and number of zeros is not there in this problem. So this will be 0, p minus z is 3, so this will be minus 8 by 3, so this will comes out to be minus 2.667. So we have centroid at minus 2.667, and the angle of asymptotes, the first angle is 60 degree, the second one is 180 degree, and the third one is 300 degree. In step 5, we will calculate the breakaway point. So let me write here. So step 5 is the breakaway point. So to calculate breakaway point, as we discussed, that first we will calculate the characteristic equation 1 plus gs hs equals to 0. So since the value of gs hs is given to us, this is equals to k by s plus 3, s plus 5. So we will put this value here. So 1 plus k divided by s plus 3, s plus 5 equals to 0. So if we will solve this, we will get s cube plus 8s square plus 15s plus k equals to 0. In the second step, we will calculate this value characteristic equation in terms of k. So this will be k is equals to minus s cube minus 8s square minus 15s. And in the third step, we will differentiate this value with respect to s. So dk by ds we will calculate. So this will be minus 3s square minus 16s minus 15. And the root of this equation equals to 0. Root of this equation will give us the breakaway point. So this will be 3s square plus 16s plus 15 equals to 0. We can solve this for s1 and s2. There will be two roots for this equation, equals to minus b minus 16 plus minus under root b square, 16 square minus 4 into 3 into 15 divided by 2 into 3. And we will solve these, we will get two values of s, which will be minus 1.213 and minus 4.119. So out of these two values, only one value is the valid breakaway point. Now in the previous slide we already discussed that the breakaway point lie between 0 and minus 3. Hence we can say this value is the valid breakaway point. So the valid breakaway point is minus 1.213. Okay, so next let's move to the next step. The next step is intersection with imaginary axis of root locus. So let us, this is step number 6. Step 6, the intersection of root locus with imaginary axis. Now to calculate the intersection points of root locus with imaginary axis, we discussed these steps. The first step is to calculate the characteristic equation 1 plus gs hs equals to 0. See, we already determined this value. This value comes out to be s cube plus 8s square plus 15s plus k equals to 0. Now in the second step, need to construct the Routh array. So we already discussed how to construct the Routh array in our previous lectures. So this will start with the highest power of s, which is s cube, s square, s to power 1, s to power 0. And the coefficient, first row coefficient will be 1. First it will be 1. It will be 1, and the next element of this first row will be 15, and the next element will be 0. The first element of s square will be 8, and the next element will be k. The next element will be 0. The first element of s to power 1 will be 8 into 15 minus k into 1 divided by 8. So this will be 120 minus k divided by 8. The remaining terms will be 0 and 0. So in the next step, to calculate the intersection point of root locus with imaginary axis, we will determine the value of k margin. So the k margin value is the value of k which makes any row equals to 0. So let us suppose we want to make this row equals to 0. Then what we will do, we will put the value of k equals to 120. So when we will put this value of k is equals to 120, this will make this s to power 1 row equals to 0. So the k marginal value is equals to 120. Now in the next step, what we will do, we will form the auxiliary equation above the row 0. Then this is the row which is above the 0th row. So we will form the auxiliary equation of this row. This will be as equals to 8s square plus k s to power 0. So this will be 8s square plus k. So the next, we will put this value of k marginal instead of k. So this will be 8s square plus 120, and the roots of this auxiliary equation as equals to 0 will give the value. So we will find the roots of this characteristic equation. So let us put equals to 0. So the root of this equation is s is equals to minus 120 divided by 8 square root. So this will comes out to be plus minus j 3.873. So this is the complex value is 3.873. So this is the intersection point of root locus with the imaginary axis. Now the step number 7, since there is no complex roots in our problem, so we will not determine the step number 7, which is the angle of departure and arrival. So as we already discussed that, let me write in the next slide, step number 7. Step number 7, angle of departure and arrival. Since there is no complex roots in the problem, so we will not determine this angle of departure and arrival. Now Let us draw the root locus by summarize all these points. So we will draw this root locus on a normal graph paper. So this is a normal graph paper in which I have a horizontal axis, which is the imaginary axis, real axis. This is the horizontal axis, real axis, and this is the j omega axis, the imaginary axis. On this, first we will locate the poles and zeros. So in our problem, we have three poles at s is equals to 0. Here we have s is equals to 0, we have first pole, and we have one pole at s is equals to -3. Suppose this is -1, this is -2, -3, -4, and -5. So we have pole at -3 and -5 as well. So this is the pole 0 diagram of this root locus, and the section in which root locus lies, we already find out that the section at which the root locus lie, let me select another pen here. So let us suppose the section on the root locus lie on the real axis is this one, the first one. It will start from the pole and terminate at the breakaway point, and the next section start from -5 and terminate at -infinity. So this will goes up to -infinity, this branch. So these are the two branches of the root locus lie on the real axis. This we already discussed. Next point is angle of asymptotes. First we need to find out the centroid, which is -2.667. So this is -2. So the centroid lie at -2.66. So this will be C centroid. Let me denote it as C, which is -2.667. So at centroid, from centroid we will draw the angle of asymptotes. Now if you remember, we determine three angle of asymptotes: theta 1, which is 60 degree, theta 2, which is 180 degree, and theta 3, which is 300 degree, or you can say -60 degree. So from centroid we will draw these three angle of asymptotes. So let me take a protractor to draw the angle of asymptote. Now to calculate, first the angle of asymptote is 60 degree. So let me set this at 60 degree, and I will put this here at 2, and I will draw the angle 60 degree angle. So I will draw a 60 degree angle here. So let me again select this. Okay, so at 60 degree I'm connecting these with a dotted line here. I'm connecting it with a dotted line. So this is the first angle of asymptote. Now the second angle of asymptote is at -60 degree at this same point. So let me set this at -60 degree here. So again I'm connecting with a dotted line. So this is your asymptotes, which will be the lines, the parallel, and the third one is 180 degrees. So this will be go along with the negative real axis. So this will be the this angle. This will be the third angle of asymptote. So these three dotted lines will be three angle of asymptotes for this question. Okay, so then the next step, we determine the breakaway point. So breakaway point we determine at point -1.213. So let me locate this breakaway point. So this is 1, this is 1.2. Suppose this is the point breakaway point, which is -1.213. So this point, breakaway point, the root locus will intersect this breakaway point, or you can say this is the intersection point of root locus with the real axis. And in the next step, we also determine the intersection points with the imaginary axis, which was plus minus j 3.873. So let me locate these. This is 1, 2, 3, and 3.8. Let us assume that this point is here, 3.8 j and minus 3.8 j something at this point, minus 3.8 j. Now this point is the point where a root locus will intersect with the imaginary axis. So how this root locus branch will this will emerge from this point, breakaway point. This will emerge from this breakaway point, and it will go along this asymptote, and it will intersect this point 3.87, and it will go along with this to infinity. This will go along with this infinity, and similarly, since the root locus is symmetrical about a real axis, same this will emerge from this breakaway point, and it will intersect this point minus 3.87 and go along with this asymptote. So this is the branch of root locus. This is the third branch of the root locus. So the remaining branches, this one is the first branch on the real axis, this is the second branch on real axis, and this is the third branch of the root locus. So overall, this is how we will draw the root locus by combining all the steps. I hope you understood this lecture. Thank you.